Okay, let's take the derivative of this function. So the very first thing I'm going to do is I'm just going to rewrite this as y is equal to, and then x squared plus 6x plus 5. And then I'm going to say it's to the power of 1/2. So just rewriting it without the radical. And now we're dealing with a composite function. So technically we're going to use our formula, and that is dy dx is equal to dy du times du dx. But let's think about what that is, right? Like what those things actually are. So this is the derivative of the really of the outside function, okay? Because we're just going to call this inside part u, and then this part's going to be the derivative of the inside function. So if we want, that'd be fine. We could change this guy into u and then take the derivative that way. But I'm just going to show you like a quicker way, right? Let's just take the derivative like we're used to, but just ignore this part for a second, right? Like we're just going to deal with the outside of the function. So just leave out all this stuff in brackets. Okay, so let's take this 1/2 and pull it and bring it down front, and then we'll subtract 1 like we always do. So we'll do that first. So we'll say y prime is equal to, actually we should use the notation they told us. So that was y, so we'll say dy dx is equal to, so bringing that 1/2 down, and now we have x squared plus 6x plus 5, and then to the power of, so we still have to subtract 1, so that ends up being negative 1/2. Okay, so that was the derivative of my outside function, right? I just still have u written in there is all I've done without actually changing it to a u. So that is this part. So then I also just now need to multiply this by the derivative of the inside function. So the derivative of that guy. So that would just be, so bringing the 2 down, that would be 2x plus 6. And there you go. That is this equation. So it's not as bad as you think once you start seeing the pattern there. So now we should just clean this up though. So this negative 1/2, right? That really means this term is going to be down in the denominator as a square root. The 2's down there already, so we're just going to have this part is going to be up in the numerator. So we've got 2x plus 6 over, and now down in the denominator I've got 2, this one, and then times the square root of x squared plus 6x plus 5. And the question said that we do not need to rationalize the denominator. But I guess there is something we can still cancel here, right? We've still got 2, 6, and the 2 in the bottom. Why don't we factor that 2 out of the numerator? So now we've got 2 x plus 6, or sorry, x plus 3 over 2 square root x squared plus 6x plus 5, and then our 2's cancel. So we have x plus 3 over the square root of x squared plus 6x plus 5.